Okay, today we're going to be talking about similarity transformations. The reason these are just going to be similar is because we're going to use a dilation and then another rigid motion. So since the shapes aren't going to be equal, it's not going to be congruent, it's just going to be similarity. So compositions of rigid motions and dilations are going to map pre-images to similar images. Again, they're similar because the distance, the length is not going to be the same. It's going to have a scale factor that is going to enlarge it or it's going to reduce it. So for this reason, they're called similarity transformations because they're similar figures in the end. So two figures are similar if and only if. What is if and only if? Yes, it is a biconditional statement. So two figures are similar if and only if there is a similarity transformation that maps one figure onto the other. Let's look at some examples of this. Okay, our first example is going to be drawing transformations. So let's say I have triangle DEF, and that's going to be my original triangle right here. And I've given you the vertices, and then I've graphed these vertices. So I want to know what is the image of triangle DEF when you apply this composition. So, of course, you start from the inside out. So I'm going to reflect it over the y-axis, and then I'm going to do an enlargement of 1.5 times. So let's start with reflection over the y-axis. So what do I do when I reflect it over the y-axis? Well, I'm going to say if I've got the y-axis here and E is in 1 point this way, E prime will be 1 point that way. Okay? So the reflection over the y-axis of D is going to give me a new point of -2, 0. Reflection over the y-axis of E is going to give me the new point E prime, which is -1, 4. And reflection over the y-axis of F is going to give me the new point F prime, which is -4, 2. So then I graphed my new prime points. So reflection led me to here. Now, I've got a composition going on, so I've got to do the dilation next, and my final answer will have a double prime. So I moved from original to prime, then I'm moving from prime to double prime by doing the dilation. So the dilation is going to be to enlarge it 1.5 times. So I'm going to take T prime, D prime, and I'm going to multiply each one by 1.5. So -2 times 1.5 is -3, and 0 times 1.5 is 0. -1 times 1.5 is -1.5. 4 times 1.5 is 6. -4 times 1.5 is -6. And 2 times 1.5 is 3. So these will be my new prime points, and they will also be the composition of the dilation of 1.5 and the reflection over the y-axis. So my new triangle would be D double prime, E double prime, F double prime, and I've drawn it right here. As always, if you have questions, you can ask them on Remind. You can rewatch the video over and over again. And if I've made a mistake, please point it out for me because I'm doing the best I can. Alrighty, let's look at another example. What is a composition of rigid motions and a dilation that's going to map the triangle RST, which is the one in green, over to PYZ, which is going to be the one in pink? All right, so if I'm starting here and I'm ending up here, first of all, it looks like I've done a rotation because if I reflect it and then translate it, this is not the same shape, right? Because if I just reflect it, my triangle is going to be going in this direction, and if I move that down, it's not the right shape. So that says reflection isn't happening. What is happening is a rotation. So I'm moving 90 degrees here and then 90 degrees here. So I'm going to rotate it 180. So what is my rotation rule? So if I rotate, the rule is going to be a rotation of 180 degrees around the origin. XY becomes -x, -y. So if I start with point R, which was 1, 1, and it becomes negative x, negative y, it's now going to be negative 1, negative 1. Point S becomes negative 1, negative 3, and point T will become negative 3, negative 1. Okay, so what I did was just faintly in the blue, I showed you what happens when I just rotate that triangle 180 degrees. Okay, so I've rotated 180 degrees, and this blue triangle is the new triangle that I would get. But I don't stop there. Now I've got to do a dilation. So if I can count, because these aren't given to me, the units here, this is 2. Then I'm going to count the units here in pink, and it's 4. So then I'm going to divide 4 by 2, and I'm going to get my scale factor of 2. Okay? So my dilation of 2 is what's going to be happening to all of these new blue points. The dilation rule then is going to be the dilation by a scale factor of 2. So I'm going to multiply whatever x is by 2 and whatever y is by 2. So I'm going to take the point that's r, negative 1, negative 1, the point r prime, the point that's s prime, which is negative 1, negative 3, and the point that's t prime, which is negative 3, negative 1. And both of these are going to be multiplied by 2, giving me negative 2, negative 2, negative 2, negative 6, and negative 6, negative 2, which is exactly what triangle PYZ is. So this is how you do a composition of rigid motions and a dilation and figure out what has to happen to get from this triangle to this triangle. So if you have any questions about anything, just send me a message on Remind, or you can contact your teacher by Google Classroom, and I will see you tomorrow.